In this video, I'm going to talk about equivalent linear systems. However, for our first example, we're going to solve a system of linear equations by graphing. And we're going to review the two methods that we learned, the intercept method and the slope-intercept method. So let's start by graphing x plus 2y equals 10 using our intercept method. We're going to first look for the x-intercept. And to do that, we're going to let y equal 0. And then we're going to look for our y-intercept, and in which case we're going to let x equal 0. So let's start with the x-intercept. We get x plus 2 times 0 equals 10, and we're left with x equals 10. So we have an x-intercept of 10 and 0. Next is the y-intercept. We let x equal 0, so we get 0 plus 2y equals 10. Which means that 2y equals 10. Dividing both sides by 2, we get y equals 5, which tells us we have a y-intercept of 0 and 5. Next, we're going to graph these 2 points. So here's 10 and 0. Here is 0 and 5. We'll connect these points with a line. I'll try my best to make a straight line. And that is equation A. So label our equation. All right. Next line, we'll call it equation B. And I'm going to keep these the same color for this example. So we want to use our slope-intercept method. So that means we need to isolate for y. So the first thing to do is minus 4x from both sides. So that leaves me with a negative y on the left side. I have minus 4x minus 14 on the right side. Next, divide each term by negative 1. So that gives me y equals 4x plus 14. So we have our y-intercept of 14, and we have our slope of 4. Now remember, a slope of 4, m equals 4, is the same thing as 4 over 1, or is the same thing as negative 4 over negative 1. And you'll see why I've written that in just a moment. So let's graph that line. So starting at 14, you see if I went up 4 and over 4, I'd end up somewhere up here. So it's easier if I use the negative 4 over negative 1. So that would be down 4. 1, 2, 3, 4. And to the left 1. Let's do that again. 1, 2, 3, 4. And to the left 1. And you notice it's going to hit the line right here at negative 2 and 6. So let's draw on that line. That is line B. And we see that these two intersect. Therefore, xy equals negative 2 and 6. The point right here. All right. So now let's talk about an equivalent linear system. First of all, we're going to make an equivalent linear system and then discuss what does it mean. In part B, it says to add and subtract the two equations in the system, and we're referring to the system given above. And then we're going to graph these two new equations. So when we say add and subtract, it's simply that. We're going to take our two equations, x plus 2y equals 10. We're going to add it to 4x minus y equals negative 14. So I'm going to put a little plus sign here to remind myself that I'm adding these two equations. And we add them column by column. So x plus 4x, so we have 1x plus 4x, that gives me 5x's. If I have a 2y, so I'm going to write this here, if I have 2y plus a negative y, so 1y, that's 2 plus negative 1, or 2 minus 1, so that leaves me with 1y. And then we're going to take the 10 plus the negative 14, or same thing, 10 minus 14, that is negative 4. I'm going to call that equation C for now. Now let's take the two equations again. We have x plus 2y equals 10. We have 4x minus y equals negative 14. And now I'm going to subtract the two equations. So the first one I have 1x minus 4. So that's going to give me negative 3x's. Then I have 2 minus negative 1. That's the same thing as 2 plus 1. So that's plus 3y's equals 10 minus negative 14. That gives me 24. We're going to call this equation D. So now let's take these two equations, write them in slope-intercept form, and we're going to add them to the graph above. So for the first one, equation C, I'm going to isolate for y. So notice we get y equals, I'm going to subtract 5x from both sides, and I'm left with negative 5x minus 4. Similarly with the next one, I'm going to isolate for y. So I'm going to get 3y equals, I'm going to add 3x to both sides. Then I'm going to divide each term by 3. So that gives me y equals 3 divided by 3 is 1x, plus 24 divided by 3 is 8. So let's quickly look at these. So the y-intercept for here is negative 4. The slope is negative 5. So let's write out the slope. So that means our slope, m, can be written as negative 5 over 1, or we can write it as 5 over negative 1. So the first one is stating go down 5 into the right one, or go up 5 into the left one. So let's start there. So starting at negative 4, and remember the slope says go down 5 and to the right. And you see that goes off the graph again. So it's easier for us to go up 5, 1, 2, 3, 4, 5, and to the left 1. And then if I go up 5 and to the left 1, notice that line C goes through the same point of intersection. When I added the first two equations, it made me a new line that goes through that same point. All right, let's go to line D. Slope, or y-intercept of 8, a slope of 1. And remember, that can be written as a slope equal to 1 over 1, or if we like, negative 1 over negative 1. So let's see which one works best. So let's start at 8. If we go up 1 into the right one, we see we're not going to hit any of the lines. So let's go down 1 into the left one, and notice even line D goes through the same point of intersection. The point of intersection of negative 2 and 6. So we added and subtracted the equations from above, and it made us two new lines that go through the same point of intersection. Okay, so now let's talk about what an equivalent linear system is. So an equivalent system of linear equations is when two or more equations have the same solution. So these two equations here, which I'm going to highlight, this one and this one, or this one and this one, have the same point of intersection as this pair of equations here. So that's why they're called equivalent. They have the same point of intersection. What would be the simplest linear system that would have the same solution as the one given above? So if I said, look at this graph, draw me two lines that go through these same points and give me their equations. One of the simplest would be the vertical and horizontal line that go through these points. So there's the vertical line. Here is the horizontal line. Now the equation of these lines, you might have to recall, if I have a horizontal line, notice all the y values are 6. So that means this equation is y equals 6. It doesn't matter what x is, y is always equal to 6. So now let's look at the vertical one. What is true about all the points on the vertical line? If you take a close look, all the points on the vertical line have an x value equal to negative 2. And you should notice right away that these two lines are equivalent to the point of intersection. So the black lines, the blue lines, and the red lines are all equivalent to each other because they all pass through the same point of intersection. So let's go talk about that. So the system of linear equations, x equals 2 and y equals 6, is also equivalent to the other systems we have shown above. But we sometimes say it's written in a simpler form because it directly gives us the solution. So therefore, this system of equations and this system of equations are all equivalent linear systems. And again, why are they equivalent linear systems? Because they all go through the same point of intersection, or they all have the same solution. So now that we know what an equivalent linear system is, let's look at how can we get it to this nice simple one. So example 2. Using the equation from example 1, how could we have added or subtracted this system to end up with that vertical line? And remember, the vertical line was x equals -2. So looking closely at these two equations, A and B, if x is equal to -2, notice there is no y value shown here. So how can I get rid of these y values? By adding or subtracting these two equations. Let me help you with the first one. I'm going to keep a the same way. I'm going to say that a is x plus 2y equals 10. That's a. But I want to get rid of the y value by doing addition or subtraction. But I'm going to have to do something else first to b. I'm going to take b and I'm going to multiply it by -2. Let's see what happens. That means I'm going to multiply everything in this by -2. So that gives me -8x plus 2y equals 28. And now I'm going to subtract these two equations. Well, if I do 1x minus -8x, so let's do to the side, 1 minus -8, that gives me 9x's. 2 minus 2, that's 0. The y's have now disappeared. And then I have 10 minus 28. Well, if you look at that, that is -18. And notice, if I divide both sides by 9, I end up with x equals -2. I just found the x value for the point of intersection, or, if you like, that is the vertical line that passes through the point of intersection. All right, let's try this one more time and see if you can do this one yourself. How could I add or subtract these two equations, a and b, in order to get a horizontal line? And in this case, we know that y needs to equal 6. Therefore, there is no x value. So how can I add or subtract these two equations with a bit of multiplication to get rid of the x value? So we're dealing with this part now. So pause the video, try it yourself. Hopefully you've tried that. So what I would do is I would take a, I would multiply it by 4. A multiplied by 4 gives me 4x plus 8y equals 40. I would leave b the way it was. So b is 4x minus y equals -14. Then I would subtract. 4x minus 4x is 0. 8 minus -1, that gives me 9y's. 40 minus -14, that gives me 54. And it just happens to be I got 9 again. Doesn't always happen this way. I'm going to divide both of these by 9 to get rid of that coefficient from the y. And that tells me that y equals 6. And notice that matches what we started with. So this would be the y value for the point of intersection, or more specifically, it would be the horizontal line that passes through the point of intersection. Final example for today. Is the following linear system equivalent to the linear system given in example 1? And remember, to be equivalent, this is the important part, it means that these two equations must pass to the same point of intersection, which we already know from above was -2 and 6. So we could go and graph it, we can use substitution, but the most efficient way to check to see if a point belongs to these lines is to do our verification. So we set up our t-charts. 2x minus 3y equals 18. 4x plus 7y equals 8. And then we just check our work. So 2 times -2 minus 3 times 6. That's -4 minus 18. That is -22. That is not even close to 18. So we can stop there and say it's definitely not an equivalent linear system because this point is not on this line here. But let's check the second one just for fun. We get 4 times -2 plus 7 times 6. That is -8 plus 42. And that gives us 36. This isn't even on the line as well. So this point's not on either of these lines. So let's conclude. So therefore, the linear system given here is not equivalent to the system given in example 1. Here are some questions from the book I'd like you to try. And again, if you have questions, please contact me. And good luck.